everyone, this is Babitha, working as Assistant Professor in the Department of ECE at Institute of Aeronautical Engineering. In this session, I'm going to discuss about what is meant by multi-stage amplifier and classification and distortion and different coupling schemes which are used in the multi-stage amplifiers. So, while coming to the contents, first of all, I'm going to discuss about what is meant by multi-stage amplifier and what is the purpose of multi-stage amplifier and what are the different types of multi-stage amplifiers and distortions which will occur in the amplifiers and different coupling schemes which will be useful in the multi-stage amplifiers in order to form the multi-stage amplifiers. So first of all, we have to know what is meant by multi-stage amplifier. So generally by using the bipolar junction transistor as well as metal oxide semiconductor field effect transistor, we can able to form single stage amplifiers in order to get the gain in terms of voltage as well as current, and in order to get the input impedance as well as output impedance from the amplifier circuit. That is nothing but required parameters we can able to get from the single stage amplifiers. But what is the drawback of this single stage amplifier here? It is in some practical applications, the gain provided by these single stage amplifiers are not sufficient, so that we cannot able to run the some of the practical applications using the single stage amplifiers. So that's why in order to improve the gain as well as amplifier parameters, we are moving for the multi-stage amplifiers from the single stage amplifier. So here what is meant by multi-stage amplifier? If we connect the several or two or more amplifier stages, if we interconnect the two or more two or more single stage amplifiers in order to make the multi-stage amplifier. So what is meaning of connecting the two or more stages? That indicates the cascading of stages. Cascading is here the output of one stage we are connecting to the input of the next stage. Okay, so here the coupling of the one stage to the next stage we can do in different ways. By using different coupling schemes, we can able to form the multi-stage amplifier here, or else in some cases we can directly connect the output of the first stage to the input of the next stage. So here which part of the amplifier we can call it as the stage means each amplifier in the multi-stage amplifier we can call it as the stage here. So several stages are interconnected, so that particular configuration we can call it as the multi-stage amplifier. So here for example, to make the multi-stage amplifier, I am considering two single stage amplifiers, two single stage BJT amplifiers. And these two are in common emitter configuration I am considering here. This is the transistor in NPN configuration, and this is the base, collector and emitter terminal of the transistor. And for this transistor, we are providing the potential divider by using two resistors in the parallel combination. The two are R1 and R2 resistances. So these R1 and R2 are providing the necessary biasing required for this amplifier stage. And we are using one more resistor, that is source resistor, that is for applying the input signal to the amplifier stage. And for this amplifier, we need to provide the supply voltage, that is VCC, and the bypass capacitor CE in order to bypass any noise or disturbances which are present in the output signal. So this is the first stage of our multi-stage amplifier. So in order to make any transistor as amplifier, here our assumption or requirement here it is amplifier should operate in the active region. So when the transistor is going to operate in the active region means when we apply the forward bias to base emitter junction of the transistor and reverse bias to collector to base junction of the collector to emitter junction of the transistor. There is nothing but between these two we have to provide the forward bias, and between collector and emitter we need to provide the reverse bias. When we provide the biasing in this way, we can able to operate the transistor in active region. Once the transistor is operating in the active region means it will provide the amplification. And along with this active region of operation, we have to provide the proper biasing here. That is, we are providing by R1 and R2 resistor by using the voltage divider biasing here. Actually, we are having different biasing techniques in order to operate the transistor in the amplifier or in the active region. Why we are preferring only voltage divider biasing here it is, if you take the fixed bias circuit, in the fixed bias circuit, the voltage level is fixed and we are getting the corresponding collector current is also fixed. But in that case, the stability factor we are getting very high. So in order to operate the transistor in the active region and in order to make the operating point as stable, the stability factor should be less. So fixed bias circuit is providing the stability factor is high so that it is not providing the stable operating point. So that's why fixed biasing circuit we are not preferring in order to operate the transistor in the amplifier. And next we are having the emitter feedback biasing circuit. In that case also the stability factor value is somewhat less compared to the fixed bias circuit. But in that case the collector current is varying due to the temperature variations as well as beta variations of the transistor. So because of the two reasons of changing the collector current, the stability factor value also varying. So once the stability factor value is varying means the amplifier will not operate in the active region. The stability factor it will be less. So once it is not operating the active region means we cannot get the proper amplified output across the amplifier. So that's why we are also not preferring the emitter bias circuit. But if we take the voltage divider biasing circuit, it can able to provide the proper stability factor almost that is equal to 1, and the variations of the collector current due to the temperature as well as beta are nullified in this particular voltage divider biasing circuit. So that's why in most of the cases whenever we wanted to operate the transistor in the amplification purpose, we will utilize the voltage divider bias. So because of that reason, we are operating the transistor using voltage divider biasing here. And here across the collector, we will take the output, or else we can call it as BC1. So this is the first stage only. This is the single stage amplifier. It will provide some voltage gain, current gain, input impedance as well as output impedance. I have already mentioned when you are taking the single stage amplifier, it cannot provide the sufficient gain in order to operate for practical applications. For example, if I take one loudspeaker circuit, loudspeaker, in order to operate that loudspeaker, we have to provide the large signal. The signal coming from the single stage amplifier is not sufficient to run that loudspeaker. So in that particular applications, we can use the multi-stage amplifier. So in order to make it as multi-stage amplifier, I am considering one more stage of this common emitter configuration. With collector resistance RC2 and here it is RC1 and emitter resistance RE2 and the bypass capacitor Cu2. And similarly, again to provide the biasing for this stage, we are using the potential divider network R1 and R2, and the supply voltage is common for all the stages. And now the output we will take across the second stage. This is the second stage. And here we can also use one more capacitor in order to connect the input signal to the first stage, that is Cin capacitor. So the Cin and Cc are the coupling capacitors, and Ce1 and Ce2 are the bypass capacitors here. So here, to make the multi-stage amplifier, I have connected the output of the first stage to the input of the next stage. That is nothing but collector of the first stage to the base of the next stage. So in order to interconnect these two stages, here I can make directly the output of this one to the input of the next stage, or else by using different coupling devices also we can able to make the multi-stage amplifier. So in this particular case, this particular second stage also providing the different voltage gain, current gain, and input output impedances. So when we are connecting the single stages to make it as the multi-stage amplifier, in that case gain is also multiplied here. The gain value is also multiplied here. So the overall we will get the gain is more compared to the single stage amplifier. Okay. So the same circuit I am considering again here. So this is the first stage and this is the second stage, and this is the coupling device. We can use either resistor or capacitor, or else we can also use the transformer in order to couple the two stages. So here we are providing the input voltage V1 and we are taking the output in the second stage, that is V0. So if we take the overall voltage gain of this multi-stage amplifier, that is the product of the gains of individual stages in the multi-stage amplifier. So the overall voltage gain I am taking here it as AV, and that is equal to AV1, that is the gain of the first stage, into AV2, that is gain of the second stage. Okay, so the output of the first stage is V2 and the input of the first stage is V1. So voltage gain is nothing but the ratio of output voltage to input voltage. So that's why for the first stage voltage gain V2 by V1 multiplied with the second stage output voltage is V0 and second stage input voltage is V2, that is coming from the output of the first stage. So that's why here also V2 and here also V2. So the gain of the second stage here it is V0 by V2. So if we find the overall voltage gain, that we will get it as V2 will get cancelled, that is V0 by V1. So where AV is the overall voltage gain, AV1 is the gain of the first stage and AV2 is the gain of the next stage. So in this particular condition, we have considered only two stages. So similarly, we can connect n number of single stages to make it as the multi-stage amplifier. In that case also we will get the overall gain is the gains of that individual n stages here. So here we have taken two stages, so that's why we have multiplied the gains of the two stages only. In this way, if you connect the n number of multi-stage amplifier, means you have to take the gains, the multiplication of the gains of all individual stages in the n multi-stage amplifier, so that the overall gain will be increasing. So what are the advantages of this multi-stage amplifier? The first thing is the gain is increasing very high. How many number of stages we are increasing in the multi-stage amplifier, according to that the overall gain of the system will increase here. And the improve in the Q point is nothing but the operating point stability will increase here in order to connect the more number of stages. And the input impedance value is also increasing here, and also this input impedance values depends upon which type of coupling device we are using and which type of input signal we are providing across the input stage of the amplifier, and also increasing the output impedance. And if we interconnect more number of single stage amplifier, the bandwidth of the amplifier will also increase. Bandwidth of the amplifier indicates it is the high frequency range minus low frequency range of the applied signal. So this bandwidth range will be increased. That is nothing but the amplified frequency signal range will be increases if we make the multi-stage amplifier. So if we observe all the advantages, all the parameter values are increasing here along with the operating point. Overall voltage as well as current gain is increasing. Input impedance, output impedance values are also increasing, and bandwidth of the amplifier is also increasing. And while coming to the disadvantages, and the circuit complexity is very high here, and because of this complexity or increasing the number of components, the cost of the system is also very high in the case of multi-stage amplifier. Even though it is having these disadvantages, we will utilize for practical applications. And next we'll see the classification of amplifiers here. So here we will get different types of multi-stage amplifiers, depends upon which type of input signal we are using and which type of output signal we are taking, and which type of coupling device we are going to use, and which type of transistor we are going to use in the multi-stage amplifier. So different depends upon different parameters. We are having different types of multi-stage amplifiers here. So the first one is based upon input signal. So which range of input signal we are providing, either small signal or large signal, that is nothing but low frequency signal or high frequency signal. So if we use the small signal that is in the range from microvolts or millivolts range, that belongs to the small signal amplifier. And if you use the large signal, if the voltage range is in some volts, in that case it is the large signal amplifier. Small signal amplifier and large signal amplifier. Small signal amplifier can be able to amplify only low frequency range of signals, and it will provide the distortion for the high frequency range of signals. And similarly, if you take the large signal amplifier, it can amplify the frequencies above the range or high frequency signals. And if you provide any low frequency signal to this large amplifier, we will get distortion in the output circuit. And this is one type of classification. And next type of classification is based on output signal. Which type of output we are taking, either voltage or current or power amplifiers. Okay, if we take output as voltage, means it is the voltage amplifier. Okay, this voltage parameter will increases at the output. And power amplifier, so once we can take it as power, means that is in terms of voltage or current, that is nothing but both the parameters, voltage levels as well as current levels, are increasing at the output stage. And based on number of stages utilized in the amplifier circuit, if you use the single stage, so that we can call it as the single stage amplifier. If you use the multiple transistors, so that we can call it as the multi-stage amplifier. And next, depends upon which type of configuration we are using in the amplifier circuit. If you use the common emitter configuration, so that it is called as common emitter amplifier. And if you use the common base configuration, so that we can call it as the common base amplifier. And if you use the common collector configuration, so that we can call it as the common collector amplifier. So these are based upon the input signal, output signal, and the number of stages, and depends upon the configuration of the transistor. These four types of multi-stage amplifiers we can make. And next one is based on method of coupling between stages. Okay, which type of coupling device we are going to utilize to make the multi-stage amplifier. First one is direct coupling. Direct coupling means the output of the first stage we are connecting directly to the input of the next stage. And similarly, the second stage output we are connecting to the third stage directly. Without using any coupling elements, we are directly connecting the output to input of the next stage. So that we can say that one is the direct coupled amplifier. And second category in this is RC coupling. So between two stages, if you use resistor and capacitor are the coupling elements in order to interconnect different stages in the multi-stage amplifier, so that we can call it as RC coupled amplifier. And next one is transformer coupling. So between two stages, we will interconnect through the transformer, so that it is called as transformer coupling amplifier. And next one is based on biasing conditions or conduction angle of the input signal. That is nothing but how much range of input signal we are providing for the amplification. Depends upon that also we can divide the amplifiers here. So in that first one is class A amplifier. So class A amplifier is going to amplify total 360 degrees of the applied input signal. So it will amplify the total applied signal. And class B amplifier. So class B amplifier can able to amplify only the 180 degrees or half of the applied input signal. If you take class AB amplifier, it will amplify the signal range with 180 degrees to 200 degrees only. And if you take the class C amplifier, it will amplify the signal from 100 degrees to 150 degrees. That is nothing but how much portion of the input signal we are utilizing depends upon that the amplifiers are classified here. And next classification is based on frequency response. See, in this case we are having the direct coupled amplifier or radio frequency amplifiers. So these radio frequency amplifiers can able to amplify the frequency range in kilohertz. And audio frequency amplifier will amplify the signals in the range of megahertz. And microwave frequency amplifier will amplify the signals in gigahertz range of signals. So these all are the different types of classifications of the multi-stage amplifiers. And in order to interconnect one stage to the other stage, we are using the coupling device here. So what is the basic purpose of that coupling device? We will see. So later on we will see the different coupling schemes. Okay. So the first and main purpose of using the coupling scheme in order to isolate the DC signal which we are applying for the amplifier. That is nothing but to amplify the signal, it should allow the AC signal only. It should not allow the DC signal. So in order to avoid the DC content which is present in the AC signal, we will use the coupling device. And so once we are allowing the AC signal means it should block the DC signal. So by using the capacitor, we can able to allow the AC signal and we can block the DC signal. So that we can use capacitors as one of the coupling element in the multi-stage amplifier. And in order to connect one stage with the other in cascading form, we can use the coupling device to make it as the multi-stage amplifier. So here depends upon the coupling devices which we are used in the multi-stage amplifier. We are having three types of coupling. And that first one is direct coupling, and second one is resistance capacitance coupling, and the third one is transformer coupling. So in that first we'll see the direct coupling. So in the direct couple, I have already mentioned we will not provide any coupling device between the stages of the amplifier. But here if we are not interconnect the stages using any coupling device means we cannot able to isolate the DC terms. But in this particular case, when we are designing the single stage amplifiers, that particular amplifiers can able to isolate the DC terms which are present in the applied input signal. So in that way, we have to design the single stage amplifiers in the case of direct coupling. So this direct coupling is mostly used when the load is connected in series with the output terminal of the active element. For example, in the loudspeakers as well as in the headphones, we can directly use the direct coupling scheme. And next one is RC coupling. So most of the cases will prefer this RC coupling, that we can form the combination of resistor as well as capacitor between the stages of the amplifier here. So the purpose of the capacitor here, it is to allow the AC signal and blocks the DC signal. This one we go already. Okay, and the coupling capacitor which is present in the input stage as well as across the output of the next stage, it will passes the AC from the output of one stage to the input of the next stage, and also it will blocks the DC components from the DC biasing voltages in order to affect the next stage. So that is nothing but it passing the AC signal and it blocks the DC components, and it will provide the proper biasing for the multi-stage amplifier. So that because of that reason we are preferring the RC coupling more compared to the direct coupling. And next one is transformer coupling here. So in the case of transformer coupling, between the stages of the multi-stage amplifier, we will use the transformer as the coupling device. Okay, and here we are not at all using any capacitor here. Why? Because transformer itself will blocks the DC signal and allows the AC signals to the base of the second stage. And here, if we take the transformer, we are having the primary winding as well as the secondary winding. So the secondary winding of the transformer will provide the base return path, so that there is no need of any base resistance also in the next stage. This coupling is very popular because of providing high efficiency as well as impedance matching between the stages. So because of these two reasons, transformer coupling also very useful in the multi-stage amplifier. And we are telling, once in order to interconnect the different stages in the multi-stage amplifier, first thing we require the coupling devices, different coupling devices, and also we require different capacitors in order to interconnect the signal to the first stage, and in order to take the output from the next stage, and in order to bypass any distortions which are present in the different amplifier stages. So now we will see the effect of each and every capacitor in the multi-stage amplifier. In that, first I am taking the input capacitor C. So this particular input capacitance is present in the first stage of the multi-stage amplifier, and that is also at the input side. Okay, the input side will present in order to couple the AC signal to the base of the first stage of the transistor. Suppose if this Cin is not present in the multi-stage amplifier, suppose here this is my amplifier. So here I am using the Cin. Here we are having R1, R2, RC and RA. Here we are applying the input signal. So same thing, the next second stage will also get, and we are providing the VCC here. Suppose if Cin is not present in the first stage, what will happen here? It is the signal source. What is the signal we are providing here? That will come in parallel with the R2 resistance. So once our applied signal is coming in parallel with the R2 signal, means what is the biasing which is provided by using this R1 and R2 will be varying here. So once the biasing condition of the amplifier is varying, means the output which we are expecting across the output will also vary here. So we cannot expect much output gain across the first stage. So because of that reason, always we need to provide the coupling capacitor, input coupling capacitor across the first stage. If it is not there, means we will not get proper amplification because of variations in the biasing conditions of the amplifier. Okay, so Cin will allow the AC signal from source to flow in the input signals without affecting the biasing conditions of the amplifier. So that is the basic purpose of the input coupling capacitor Cin. And next one is emitter bypass capacitor, which is present in parallel with the emitter capacitor. So what is the purpose of this coupling capacitor series? Means it will provide the low reactance part, that is nothing but low resistance part to the amplified AC signal. Suppose this particular CE capacitor is not present. If you remove that, means the voltage developed across the resistance RE, okay, this resistor RE, again it will fed back to the input circuit. That is nothing but again it will fed back to the base of the first stage. That is nothing but again this signal is affecting the base voltage of the amplifier. If the base voltage of the amplifier is changing, means the input voltage or biasing voltage of the amplifier is changing here. So once the biasing condition as well as input voltage is changing, means there is effect in the output voltage. So suppose this so because of that purpose, we need to compulsory include the CE capacitor also in parallel with the RE resistor. So if it is present, means directly it will pass the amplified AC signal through it. And next coupling capacitor is the CC, collector capacitor. So the basic function of this coupling capacitor here is it connects the two stages. It is nothing but output of the first stage to the input of the next stage. Okay, and also it will isolate any DC interference between the two stages here, and it is also called as blocking capacitor because it is not allowing the DC signals. Suppose this coupling capacitor we are not including between the stages, means the output which is generating across the first stage will come in parallel with RC resistor. Okay, that is nothing but RC resistance will come in parallel with the R1 resistance of the transistor. So once these resistors combination is coming across, means again there is a change in the biasing conditions of the transistor and there is the effect in the amplifier stages. So each and every capacitor is providing one particular function in the amplifier stage. So definitely we have to include all the input capacitor, coupling capacitor and bypass capacitors in all the stages of multi-stage amplifier. If we remove any capacitor, means it will affect the biasing conditions of the amplifier and input voltage of the amplifier, so that there is a reduction in the overall gain of the multi-stage amplifier. So our basic intention of making the multi-stage amplifier only in order to improve the overall gain of the system. But if we are not including these capacitors, means there is a change in the gain. While making a multi-stage amplifier, which type of configuration of the transistor we have to use here? That is, in order to know that, first of all, we have to see in all the configurations which properties they are providing here. Suppose if we take the common collector amplifier, in this case voltage gain is very less, that is less than 1. So it is not suitable for intermediate stages. That is nothing but we can utilize this one in the first stage or in the last stage of the multi-stage amplifier, but not using any middle stages of the amplifier. And if we take the common base amplifier, in this case also voltage gain is less than 1, so that we cannot useful for the cascading purpose. And if we take the common emitter amplifier, in this case if we take the voltage gain as well as the current gain, both are greater than 1 in this case. So that's why, because of this reason, common emitter amplifier mostly suitable for making the multi-stage amplifier here. Okay. So now we will see all the coupling schemes with the circuits. I have already mentioned in the direct coupling schemes, we don't have any coupling element. Okay, and generally this direct coupling amplifier is useful for low frequency applications. Okay, and this is the circuit for the direct coupled amplifier here. So this T1 is the NPN transistor and T2 is the PNP transistor, and again T3 is the NPN transistor. That is nothing but we are interconnecting 3 stages without using any coupling element in the case of direct coupling. So signal which we are passing to the base of the transistor directly, and after amplification the collector voltage of this first stage directly connected to the base of the next stage, and again the collector of the second stage voltage is connected to the base of the next stage. So the final amplified signal we can expect across the final stage, that is the third stage here. Okay, so here why we are using the NPN transistor in the first stage and PNP transistor in the next stage means, so here any variations in the NPN transistor are nullified by the any variations in the PNP transistor. Why? Because in the case of NPN transistor and PNP transistor, all the current levels as well as voltage levels are in opposite polarity. Okay, suppose some IC current which is flowing in the T1 transistor is positive, means the collector current which is flowing in the PNP transistor is negative here. So any variations or any fluctuations in these two stages are nullified by this positive and negative polarities. Those will be compensated so that we will get the final overall gain across the output. And one more thing here, it is any variation or rise in the collector current due to beta parameter in any transistor is cancelled by decreasing the collector current in other transistor. Why? Because if we take two similar transistors also with the same properties and with the same doping levels, in that case also the beta value will be different. For the two similar transistors also beta value is different. So because of that reason, any variations in the collector current is compensated here, even though we are not providing any coupling device. So while coming to the advantages of this direct coupled amplifier, it is very simple circuit. Why? Because we are not using any extra circuit elements here, and cost is also very less compared to the remaining two coupling amplifiers. And while coming to the disadvantages, it cannot applicable for high frequency range of signals. That is the main drawback of the direct coupled amplifier. And in this case, operating point is shifted due to the temperature variations. Okay, if we vary the temperature conditions of this circuit, the operating point is shifting towards the cutoff region or towards the saturation region. So once the operating point is shifting in the cutoff as well as in the saturation region, means there is a clipping in the output signal. If we shift in the saturation region, there is a clipping in the positive half cycle. And if the operating point is shifting in the cutoff region, in that case, there is a clipping in the negative half cycle. So in order to get the faithful amplification, the amplified signal should be like this, with improved amplification and without any distortion or clipping. But in this case, we are not getting this type of signal, but we are getting this type of signal. So because of that reason also, we will not use for many practical applications this direct coupling. and only we can utilize this direct coupling for low frequency amplification as well as low current amplifications. Only for a few range of signals only we can able to utilize this direct coupling scheme here. And second type of coupling here it is resistance coupling and capacitor coupling, RC coupling amplifier. So if you see the construction of this RC coupled amplifier, I've already taken this. So this is the first stage of the multi-stage amplifier and this one is the second stage. So in order to interconnect these two stages, I'm using this RC as the coupling elements here. And here the purpose of the Cin is to provide the applied AC signal to the base of the first stage, and R1, R2 resistors are used to provide the biasing for the transistor T1, and here also R1, R2 provide the biasing for the transistor T2, and CC, the coupling capacitor, in order to connect the output voltage to the input of the second stage, that is base of the second stage. And this coupling capacitor CC across the last stage, which is used to provide the output voltage here. And this emitter bypass capacitors across both the stages are used to provide the path for the amplified AC signal. And in this particular case, if I apply my input voltage to the first stage, and because of this biasing conditions and all, this transistor will operate in the active region. So once the transistor is operating in the active region, in that case if you provide the input signal across the output of this first stage, you will get the amplified version of this particular applied input signal. And the output of this one is amplification of the input signal, and this one is through the coupling capacitor as well as the load resistor RA we are connecting to the base of the second stage. So again, actually we are providing the amplified signal as the input for the second stage. So the output of the second stage you will get as again amplified signal, that is nothing but amplitude of the signal will still increases here. If you interconnect some more stage, means again the voltage gain will improve more. And this RC coupled amplifier we can utilize for the high frequency applications as well as audio frequency applications also. And the next one is transformer coupling amplifier. So if we observe here, the main drawback of the RC coupled amplifier is it is suffering with the effective load resistance of the transistor. Effective load resistance is reducing here. Why effective load resistance is reducing means the output resistance of the second stage is depending upon the input resistance of the first stage. It is providing the loading effect here. So because of that reason, effective load resistance is reducing here. So because of that, the overall input impedance of the amplifier is making low and the output impedance is high. In order to operate the amplifier in the proper way, input impedance should be high and the output impedance should be low. But here, because of the effective load resistor in the RC coupling, it is coming in reverse way. Input impedance is reducing and output impedance is increasing. So that's why in order to overcome that particular problem, we are moving for the transformer coupling here. So this is the similar circuit what we used in the RC coupled amplifier, but instead of capacitor, we are using the transformer as the coupling element here. And again, Cn is providing the AC signal whatever we are applying to the base of the transistor, and R1, R2 are utilized to provide the proper biasing for the transistor, and Ce is for providing the amplified AC signal. It will provide the path for the amplified AC signal. And here we are not required any collector resistor here. Why? Because the primary winding of the transformer will provide the sufficient resistance for the collector region of the transistor, and the secondary winding of the transformer is connected to one end of the secondary winding is connected to the potential divider circuit, and one more end is connected to the base of the next stage. So it is directly connect the output of the first stage to the input of the next stage without using any capacitor here. Directly it will pass the AC signal only. And here these R1, R2 provide again biasing for the second stage, and the final output we will take across the second stage, that is at the secondary winding of the transformer at the secondary stage. So the basic advantage of the transformer coupling here is it will provide the best impedance matching between all the stages which are present in the multi-stage amplifier, and it is reducing the effective load resistance drawback in the case of RC coupled amplifier. Because of that reason, mostly we are preferring the transformer coupled amplifier in some frequency range of applications. Okay. So here the voltage at the primary is transferred according to the turns ratio of the secondary winding of the transformer. So this transformer coupling provides the good impedance matching between the stages of the amplifier. Generally this transformer coupling we will utilize for power amplification, that is nothing but high frequency range of signals. So in this session, we have discussed what is meant by multi-stage amplifier and how we can form the multi-stage amplifier, and what are the different coupling capacitors effect in the multi-stage amplifier, and how we can make the multi-stage amplifiers by using different coupling schemes. So if we see here, in all the coupling schemes or coupling methods, those are having its own advantages and disadvantages and applications. So it depends upon our required practical application. We have to choose any one coupling schemes to make it as the multi-stage amplifier. So if you take the direct coupled amplifier, it will operate for low frequency range of signals. And if you take the RC coupled amplifier, it will operate for a mid frequency range of signals. And if you take the transformer coupled amplifier, it will utilize for high frequency range of signals. That is nothing but different coupling schemes are utilized for different frequency range of signals here, and depends upon that we will get different frequency responses in the case of multi-stage amplifiers. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.